Good morning, everyone, and happy Friday. We're streaming live here from Tech Talks, or we're streaming the Tech Talks live here from Wolfram Technology Conference 2022 in Champaign, Illinois. I'm your host, Rebecca, and I'm joined today by Jan Brugard, who's the CEO of Wolfram Math Corps. Today we're going to be talking about the use of system modeling for conceptual designs of aircrafts, which is super interesting and a super unique topic that we haven't talked about yet this year. It's probably the most unique topic so far. How are you doing today?
I'm doing fine, thanks. Yeah.
Cool. How's the conference been going for you? I heard you gave a talk on green energy, is that right?
Yeah, I gave it on the green energy and, well, a couple of other talks too. So it's been busy, but good.
Cool.
Yeah.
Sounds good. Well, to get right into our what we're going to talk about today, from what I understand, you guys have partnered with Saab in the last year to kind of just to develop a new aircraft modeling library. Can you tell me more about that experience?
Yeah, we were developing an aircraft library ourselves, and then we happened to meet. So we are located in Linköping, Sweden, which is where Saab has their headquarters too.
Very cool.
So we met with them, and it turned out that, well, they do have libraries, they do have simulations tools for aircraft modeling, but what they're lacking is something to use at an earlier stage. All the libraries requires a lot of detailed parameters before you can have them sort of work.
Mm-hmm.
But the simulation is at its most useful if you can have it from the beginning, so you can predict how things will happen, will work. So then they wanted to develop something where you can do those details, but you would also be able to do something from a more sort of simple sort of early stage knowledge about what you're going to do.
Okay. So obviously predictive modeling is the benefit of doing these types of aircraft simulations, but what industries is that going to be beneficial for?
I would say almost all industries. It's so if you look at our customers, they would be aircraft, of course, but it could also be a gas turbine. It could be looking at a drug and seeing how to optimize that and so on. So it could be basically any industry where you want to understand better how your product or whatever you are developing actually would work in real life.
Absolutely. That seems really beneficial and very cool. So how does creating a partnership in this industry look like?
Well, it will depend a lot on who you partner with. So and as this is a local partnership, it's always about the right contact, finding the right projects where you have common interests, of course.
Sure.
And in this case, it was so obvious that they needed something that we were developing very close to what they needed to begin with, and then of course to partner with them, we got direct feedback while developing, so we can do it very well tailored to the actual need from manufacturers, rather than trying to just guess ourselves, right?
For sure.
So yeah, it's you find sort of the people that want to partner, and then there's of course all these all writing contracts and so on, which in Sweden is slightly less complicated than the rest of the world. So,
Okay.
so it's rather straightforward. We're not too bureaucratic, so yeah.
That's beneficial.
Yeah.
Cool. So I understand this hasn't come out yet, but it's going to be coming out soon.
Yeah, it will come out at the same time as the 13.2 release of Mathematic and System Modeler. So
Very
because
cool.
it depends on a few things in the new release of System Modeler.
Sure. Okay. What else is going to be coming out in that release?
Well, it's we have improved sort of the back and the simulation engine a lot, so which means that we will be able to support more modeling libraries, and for instance, there will be a rotating machinery library added where you can look into details into ball bearings or roller bearings and see all the contact forces for all individual rollers and so on. But then there are ways to sort of easier create interactive interfaces for your models and so on.
Sure. Cool. Can you show us any of this on your computer?
Yeah. So I don't know if are people seeing the computer?
I believe
screen?
so.
Yeah.
Yes, they are.
There you go. So here I have an example open from the aircraft library, and what we're
Cool.
seeing here is we have here a Pipistrel Alpha Electro, which is an electrical aircraft,
Okay.
and then over here we have another aircraft which is a glider.
Sure.
So the Pipistrel is supposed to tow the glider to tow it upward and get it up to speed, and then after a while they release and then they fly separately.
Okay.
So that's the scenario that's set up here. And so to build this, you basically drag and drop components in this environment, and then once you connect it the way you want, you can simulate that.
Very cool. So the electrical aircraft, is that similar to like the big commercial aircrafts in a way, or is that a?
This is a small one. We can
Okay.
see it. We can simulate it, and you will see what it is.
Sure.
It's a two-seater aircraft, which is you have to sort of. If you can't be too big to fit into that aircraft.
Okay.
Having to do with capacitor batteries and so
Sure.
on, of course. But yeah, so let's go here first. So this is the simulation environment, and right now you don't see the aircraft. What you see is different sort of curves showing the behavior.
Mhm.
So if I would explain what's happening here is you see both aircraft are gaining altitude, happens to be meters, so it's up to 2,000 meters. That would be 6,000 feet, something like that.
Wow.
So they're towing it upwards, and then here is where it's released, and then you see that this one is the glider, takes one path, and the electrical continues on another.
That's very cool. It makes it really easy to understand and
Yeah.
visualize in multiple different formats.
But so then talking about visualizing, of course you can get a lot of data this way and
Sure.
understand a lot of things, but it's then of course easier if you can actually see it being sort of run and see what happens. So here we see from the start how we
Wow.
start flying, and the glider follows. Well, it has the road, he needs to follow, but still you have to
Yeah.
control it so it goes as smooth as possible.
Sure.
And then after quite a while, so let me sort of skip forward here to, I think it's somewhere around here, we will release eventually, play this a bit faster, say twice the speed. Hopefully, I don't remember exactly when we can do this. And we will sort of see where we're, okay,
Oh.
there we released, yeah. And now it's flying by itself.
Very cool.
Yeah. And as you see, it's a Wolfram aircraft with a Wolfram logo on, and so
Of
it's our new
course.
fleet.
Got to keep the branding.
Yeah.
That's very cool. I have not actually, I've started at Wolfram a few months ago. I've not
Yeah.
actually seen System Modeler in action,
Yeah.
and I'm very impressed by just the complexity of it,
Yeah.
to be honest.
Yeah. So then, of course, this thing here is more to get a sense for it, but what adds the real value are these more, in a sense, the boring curves here, where you can go into all the details. You can see the battery level, or if it's a traditional aircraft, the fuel consumption.
Sure.
You can see all the rudder angles, all the forces acting on it, and so on and so forth, and get an understanding for how it actually behaves.
Very cool. So it is able. I'm assuming it predicts these types of things,
Yeah.
correct?
Yeah.
Very cool. Are you able to simulate two different scenarios to kind of make, decide what you think would be the best situation?
Yeah, so you can set up whatever scenario you like. You could let's say you want to you want to design an aircraft that is going to fly a specific type of flight, a specific range with, more or less how many passengers you want and so on.
Mhm.
And then you put in those as inputs to your model, and based on that, it will calculate the aerodynamic properties, the expected total dry mass for your aircraft, and so on. And then you give it a flight mission, you simulate, and you see the behavior, see how much fuel it would expect it to
Wow.
consume, and so on.
Wow, that's really complex.
And then if you would like to control it too, I brought the
Oh, sure.
joystick here. So, and I prepared another model for that. So
Oh,
now we will
man.
fly a 737.
Okay.
I heard that you have you're almost a pilot. I heard before.
Sure, yeah. You can count that, sure.
Yeah. So what we done here first, this is another environment. It's an open source flight simulator called Flight Gear.
Okay.
And we have connected this to system audio. Right now you see that's nothing happening really, right?
Sure.
Because we haven't started the simulation.
Okay.
So it means it's still here,
Okay.
not doing anything. But and we're actually flying over Linköping, so we're almost right over Saab's headquarters right now, where we start.
Very cool.
And we probably exactly above it, because we start over their airport.
Okay.
So then let me start this simulation here. Let's do this also so we can, and then we start. Then we see here that like this starts to update with the curves, but
Okay.
and if we go over to the flight gear, we'll see now it's flying. And now you can try to, and now it's sort of, you have it the other way around.
I had it backwards.
Yeah. And it's, I said it, so it's quite sensitive, so you
Oh.
will have a bumpy ride.
Okay.
Yeah, on purpose to make it a bit more
Sure.
fun. So
Do
so
I-
you just go pull back and forward to sort of go up and down,
Cool.
and left right to steer it.
Okay, it is very sensitive.
Yeah, and then you have a throttle, so you can sort of control the speed here.
Oh, okay.
Yeah, and as I said, on purpose I sort of calibrated it so it is sensitive and will give you a
That's accurate.
Yeah.
Gonna be accurate. You gotta. Flights are gonna be sensitive.
yeah.
Oh no.
And then so it's this gives of course a pretty nice feeling of how it actually
Yeah.
works, and then sort of give that. So
This is very cool.
Yeah.
Fun. It's like a video game.
yeah, that's right. But the difference from a video game, of course, is that at the same time we're seeing here what's happening on all the details. So the curves we see here, these are the lower part here are the
Sure.
movements you'd made on your joystick. So
Okay.
it's,
Very choppy.
yeah, and this is the, so you actually increase from 4,000 meters up to 4,600
Wow.
meters. So you elevated 600 meters, and and then you did some. We changed the velocity for a while here, where we played around with throttle and
Sure.
things like that.
That's very cool.
Yeah.
I can see this being beneficial to even, I guess, pilots in training in a way to see, to fully understand.
Yeah, if you calibrate it better.
Yeah.
Otherwise, they will not. If they fly the way this is now set up. Yes, of course
Okay.
you could do that for some initial training, getting a feeling for how it would work.
Wow, this has been really interesting. Very cool. Do you have anything else you want to share with us?
No, it's like wait, we can do one thing more with this.
Sure.
Because let me just stop the simulation, because now we perhaps want to see it in we can see the same flight that you did in system model on a replay here,
Oh no.
and in the Wolfram aircraft in this case, because we use another visualization for it.
Cool.
And let's speed it up so we don't have to wait that long, and then we can see that how bumpy your
You don't want
Your
me to
eyes
fly
is-
your planes.
so. Whoever is following this, you can choose whether to fly with her next time or not.
Yeah, I have to fly back home on Saturday, so they better not let me fly that plane.
Yeah. No, but anything else? I think there's so many things that I could be showing, but just quickly to. As I mentioned, the rotating machinery. The idea is that you have, here's power systems. I did a talk on green energy, as mentioned before.
Sure.
Also libraries that are available for that. Rotating machinery for the ball bearings.
Mhm.
So they are, and I probably have a biochemistry library loaded, a bunch of different for teaching. So the idea is that there are these pre-made components for all sorts of things. So when you put it together, you don't need to understand the maths yourself. What you need to understand is which type of components should be put together, and then
Absolutely.
the machinery takes care of the
That's
underlying math.
Really cool. That is
Yeah.
super important, because I know not everyone out there is a mathematician, and we need to make sure that everyone has equal access to this, because this is a really cool product. So that's awesome. Cool. Well, thank you so much for taking the time to show me this and letting
Yeah.
me play with the
Yeah.
simulation. That was really
Okay.
fun.
Yeah, thank you very much.
Cool. We have one more tech talk later today, and we'll be back. So see you later.